Okay, so today is a day 7, and our topic is to discuss multiplexer and multiplexer. Okay, so like, did you heard about this word before?
No, sir.
Without wasting time, going to discuss multiplexer and demultiplexer. So let's discuss firstly what is meant by multiplexer. Multiplexer. So we generally call it as mux. Shortly, we call multiplexer as mux. Okay. Okay, just focus here. So, what is the definition? So, it is a combination of circuit which is designed to work as to take 2 power n inputs along with n select line and 1 output. So, basically, this is a definition for the mux. So we design. So it is one of the combination circuit, and we design according to our use. Okay, that is, it is a combination circuit which is designed to work as to take 2 power n inputs. The sense 2 power inputs, which is 2 2 power n inputs. Or we can call it as okay, 2. So 2 power n is to 1. That is 2 power n inputs and output is equals to 1. So this is the basic definition and the working principle of mods and applications. It is used in one communication system, telephone networks. Okay, this is the basic definition and applications of similarly the block diagram for so consider a box. It's two, it's two, one. Next. And we have one output. Consider it is y. So input one. Guys, focus. Just focus. Similarly, we have 2 power 1 to 2 power n inputs, and we have only one output. And for that, we need to select n number of, sorry guys, n number of, along with n number of selected lines, in selected line. So consider here S0, S1, S2, and SN, PSN, n number of selected lines. So this is a basic block diagram of multiplexer. Okay, are you getting it right, Charan?
Yes, sir.
Okay, come on. So see, once look at the definitions, it is a combination circuit which is designed to work as to take 2 power n inputs along with n selected lines and one output. So generally we can like 2 power n inputs or 2 power n to 1. We generally mention it like an application system. What is application of this multiplication communication system? See, you're using router, your Wi-Fi router in your college. So with one router, we are taking multiple outputs, that is multiple mobile connections. Okay, and from multiple, suppose you have 4 speakers and you connected to one amplifier. So 4 inputs and one output. So generally we use the multiplication like demux and mux for communication system, telephone networks, computer memory. Okay, so this is a basic working principle of like basic diagram definition of multiplexer. Next we'll go for demux. Similarly, demux. Okay. So here it is a combination circuit which is designed to work as to take 2 power n inputs. So here we consider one input, one input along with n selected lines and 2 power n outputs. So it is a vice versa of mux. It is a combination circuit which is designed to work as to take one input along with n selected lines and 2 power n outputs. Okay. Similarly, just look at here. One is to okay, are you getting it right? One input, 2 power n outputs. So it is applications are same. Just copy pasting here. Functions. Okay, just remember this. So here, log diagram. Just have to turn the 180 degree of mux, then we'll get. So we have according to definition, one input and n number of outputs. One, two, similarly, we have n number of selected lines. So basically, the multiplexer and demultiplexer work as switching here. Switching. Okay. So consider input one, that is A1. Consider one, output put one, put two, Okay. Similarly, we have selected lines. This one, this two, yes, yeah. One, this two power. So are you getting it? See the difference. Both are same, just vice versa of marks. So here n number of inputs and we'll get one output. And for that we need to take n number of select lines. And here in the demarks, one input and n number of outputs along with n number of selected lines. So these are the basic block diagram and definition and application of. So we have different type or like a different configurations of multiplexer. That is 2:1, 4:1, 8:1, or 2 power n is to 1. So n number of multiplexer we can design. Okay. So we'll discuss firstly 2:1. So that is I'm considering 2:1 mux. Means how what is the number of n? What is value of n here? So that is 2 is to 1. N equals to 1. So so it becomes 2:1. Am I right? Yeah. Just take one box. We have two inputs. That is take input one.
Two inputs, one output.
Yeah, perfect. So I'm just writing 2:1 mux. Okay. Consider you can write any. I'm just considering I1. I1. I2. Okay. And here, how many select lines we need? Come on, Chan. According to definition, how many select lines we need to select?
Two power and
You see that you see the definition once, right? Come here, read the definition once, and you'll get the idea about it. How many selected line we need to take. Okay. Work has to take 2 power n inputs along with n selected lines. That is what is the value
one.
of n? Yeah, yes. So we need. I'll explain the why we are taking yes. So just consider yes. Okay. And output. Just consider output. So here we have n equals to 1. That is a combination 0 and 1. Okay. For 0, you can write S bar, right? Similarly, 1S, yes, okay. Can you write sum of products like this? So come here. So the multiple like mux works based on if S equals to 0, then it selects I1. Okay, are you getting it?
Okay,
Okay.
sir.
Just focus. Okay, when S equals to 0, it selects I1. When S equals to 1, it selects I2 and gives output as like this. Wait, equals to. Now, can you tell me what is our output? I1 into S bar plus I2 into yes. Are you getting it right? So when 0 S bar, when 1 yes. So if you want to get output as I1, so definitely selected lines will select S bar into I1 plus when we need to take output, if you want to get output as I2, it selects yes. Okay. So you'll understand 4 is to 1, don't worry. So based on the equation, based on the expression that we got output, so we need to make a circuit. So I'm just writing to table. Okay. So what we have, yes, in output as 5. It's very simple. It's very simple. Very simple. Just focus how I'm doing, and easily you can get it. Okay. So here S value is 0 and S value is 1. Okay. When S is 0, we have output I1. When S value is 1, we have output is I2. So this is a truth table. It's very simple. So we'll design a circuit. Okay. Come here. How many? What are the inputs we have? I1, I2. How many AND gates we require? Come on, quick answer.
Two AND gates, one OR gate.
Yeah, perfect, perfect. So we have how many input? Like how many variables here? You see how many inputs and how many outputs? I1, I2, two inputs, S bar and S. Total 4. Okay. So for that I'm writing here I1, similarly I2, yes, and S bar. Okay. So very so then input yes, curriculum. So generally we require two AND gates. So I'm drawing AND gate. I get it. So next, what is I1 into S bar? So just I'm connecting I1. I1 and S bar. It's very simple. Just connect it. And similarly, I2 into S. Just connect I2. Yes. Now we need to connect here. This is why. Do you understand how I am doing? It's very
Yes,
simple.
sir.
Yeah. Now we'll move to 4 into 1. Okay. Here you will understand how it works. 4 is to 1. 4 is to 1. Sorry. Okay. Okay. Focus here. So just consider 2 power 10. Okay. So here n equals to 2. Then it will become 2 power 2. That is 4. 4 is to 1. Okay. How many inputs we require generally? Consider 4 inputs. 1, 2, and put 4. And we have only one out. Okay. Is a 4 is to 1. Just taking I1, I2, I3, I4. Okay. These are the 4 inputs. And how many select lines? Come on, tell me fast, fast, fast. Quick
Two.
response. 2. Yeah. 0. S1. So just consider S1 and S0 as select lines. So here we have 2, right? 2 select lines. So how many binary numbers are possible?
4.
Yeah. So what are they? 0,
0,
0,
0,
0,
0,
1, 1, 0, and 1 and 1. And generally, you know, where there is 0, we keep just to S bar, S complement. Okay. So see, I'll explain how the working principle of this. Okay. So when the selected lines get 0, 0, automatically it select input I1. Okay. So output will be I1 and next S bar, sorry, S0, S0 bar and S1 bar. See here, just remember this. It's very easy. So when 0, 0, it selects I1. That is what we have. S0 is 0 and S1 is also 0. So just consider S0 bar, sorry, S1 bar, S0 bar. Okay. Similarly, we have S1 is 0. So S1 bar and S0 is 1. So just write S0. Similarly, we have S1 is 1. So just write S1 and 0. S0 is 0. So write S0 bar. Similarly, both are 1. So don't need to write anything. Just write S1, S0. So generally we select this. Okay. So when 0, 0 is there, it selects this line. When we get 0, 0, it selects this. Okay. Both. So if you want, when 0, 1 is there, I2 will select. Similarly, when 1, 0 is there, it selects both. When double 1, 4. Are you getting it? How I'm explaining it? Do you understand, right, Charan?
Yes, sir.
So what is the next output? I2 into, come on, quickly, you just tell. If you understood, you can easily tell. I2
S1
into,
bar,
yeah,
S1 bar,
so,
0.
S0, right? Similarly, I3 into S1, S0 bar, right? I'm just writing S0, okay. S1 and S0, S1 and S0, okay, okay. Next we have I4, S I4, S1 and S0. So this is our output, okay. And I'll explain the truth table for this, okay. We have S1, S0 and output Y. So we have positive combination 0, 0. Zero, 1. Okay. When we select 0, 0, we have input, output, I2, I3, I4. So this is a truth table, yeah. It's very easy, right? But just we need to remember the selected lines. That's it. Nothing else to do. You got it right?
Yes, sir.
Yeah. Based on the output, we need to design a circuit. The meeting will end in 1 minute. Please join again, okay? So what are the variables we have? S1, S0, S bar, S1 bar and S0 bar. 4 and as well as I1, I2, I3, I4. Okay. So simply I'll just connect, take I1, I2,